We're going to look at a frameshift mutation and see how the insertion or deletion of one base can cause our entire reading frame to shift. And I like to think about this one change being similar to the butterfly effect, where we have only one very small change, or seemingly small, which has a very large impact on our overall final product. So we're going to look at a normal and mutant sequence, and we can begin to compare, but right off the bat we can see that the mutant sequence is much smaller. So we look like we have a premature stop causing this nonsense mutation. So we're just going to add this stop here, and now what we're going to do is we're going to write out all of the codons for this so we can try to figure out our original codon sequence. So when we write all these out, we can see that methionine and tryptophan are the same in our normal and our mutant. So we only have one codon for those, so we have figured out that part of our codon sequence. Now we're going to begin to compare where we see this difference. And we see that this A is an isoleucine that doesn't show up in phenylalanine, which is going to make us believe that that has been added, or we have inserted that adenine into our mutant strand of mRNA. So our reading frame would shift to the right, and we can then see that this UU in phenylalanine matches up with this UU in isoleucine. So we can say that isoleucine's codon is AUU, since we have inserted the A and we have shifted everything to the right. So that would add up. And we're going to begin to compare now again. So we have the C in phenylalanine matches to the C in histidine. So phenylalanine is likely UC. And if we continue, we can see that we have an AC in thymine, which matches up to the AC in this codon for histidine. So histidine's codon is CAC. If we continue, we notice that we have a U in thymine, which matches up to our U in our stop codon. So we can say that thymine is ACU. And if we continue on, we can see that we have two A's at the beginning of both codons for lysine. So that would end up for those two A's at the end of our stop codon. So our stop codon is UAA. We're unable to figure out what lysine and glycine are, only because we have no more codons to compare them to. So we can rewrite this using our 5' and 3' and see that we have figured out most of our codons for our normal strand, and we have figured out what our mutant codon strand is. And again, we're unable to figure out lysine and glycine. That's okay. We don't have anything else to compare it to. But we should remember that all of this started with the insertion of that one adenine. And this insertion goes back to this butterfly effect of only this one base having a large impact on this protein, causing this nonsense mutation to happen and our protein to become non-functional.